Hey everybody. So in today's lesson, I'm going to be showing you how to apply what we call related rates. And you're going to need to use your knowledge of differentiation to do this. In particular, you're going to need to use your knowledge of implicit differentiation. Now, we're going to be differentiating a lot of these related rates questions with respect to time. So here's a specific example here on the left. So you have a rectangle and it has a length of 11 inches and a width of 10 inches. And the sides are changing. And the length is decreasing by 5 inches per second, and the width is shrinking at 4 inches per second. And we want to figure out what is the rate of the change, what is the rate of change of the area. So with these questions, the first thing you always want to do is draw yourself some kind of diagram so you can visualize what's going on. And then we're going to plug in everything we know. So we know that the length is going to be 11 inches, and we know the width is going to be 10 inches. Now it says that the length is decreasing by 5 inches per second. So that's a related rate. That's a rate of change. So the way that I write that, it's going to be dl with respect to dt. So the way to look at that, it's the change of length with respect to the change in time, and then that's going to be equal to -5 because it's decreasing. If you look at the width, we know here that the width is shrinking at 4 inches per second. So the same thing here, but this time I'm going to use dw with respect to t, all right, because the width is changing with respect to t. And remember, a derivative is just describing how something is changing. And we know that in this case, it's going to be shrinking and -4 inches per second. So that's basically all the information we're told. Now we want to figure out the rate of change of the area. So the way that you would write that is dA with respect to time. So again, all of these are always going to be with respect to time. So we want to figure out how fast the area is changing with respect to time. So in order to do this, we need an equation that brings everything together. So in this case, it's going to be the area of a rectangle. And an area of a rectangle is just the length times the width. So we want to go ahead and figure out the derivative of the area with respect to time. So this is where the implicit differentiation comes in. And in this particular case, because I have two variables that are being multiplied together, I'm going to have to use the product rule. So the product rule says I take the derivative of the first term, which is L. And remember, I'm doing that with respect to time. So dl with respect to time, and then I multiply that by w. Plus, I leave the L where it is, and now I take the derivative of w, which is 1, and then dw dt. So that's going to be my derivative of the area. So in order to find this, I just need to now plug in the values. So to find dA with respect to t, or in other words, to find out how fast the area is changing, dl dt, I know that is -5. The width is going to be 10, I was given that in the question, plus the length is 11, and then the width with respect to time was -4. So now it just becomes a very simple question. So -5 times 10 is -50. 11 multiplied by -4 is going to be -44. And then if I combine those two together, I'm going to get -94. So there my answer is, well, actually I need to write it down as a statement. So the rate of change of the area is decreasing, because that's the negative, at 94. And remember, it's the area that's changing. So the area in this case is going to be square inches. So 94 square inches per time, and the time in this case was seconds. So there I've got my seconds right there. Okay, and that would be your final answer. All right, if you have any questions, just let me know. I'm going to give you another example in the next video, so please be sure to check that out. Cheers.